Hello guys, so first thing is that there will be lighting talks in this room and the next room after this session. The schedule is ready, you can check on the web and the application. And now our last and but not least two speakers before the lighting talks are Pavel Odvody, aka Podvody, and Christian Himes.
Hello, so thank you for the introduction.
Hello, hello? Yeah. That sounds much better. I don't need to yell anymore. Okay, so if you want to steal my secrets, you actually have to gain full-blown code execution in the given container. And from my point of view, if someone gets full-blown code execution somewhere, I think that the secrets are like the least I have to worry about. Examples of secrets as a service is Custodia, which Christian will tell you more about in a short moment. Then we have this Vault, Keybase. There is actually a free IPA Vault as well. There is like 5 or 6 different things called Vault by different companies, like Chef has its own Vault. So yeah, it's pretty vaulty. Okay, so next up I have some diagrams. So let me show you how to basically process this and show a few basic steps how to incorporate this into your infrastructure if you're not doing it like this already. So please raise your hands. Who uses encryption at rest for your secrets database? Okay, good. So if you are not doing that, this is how you can do it. So you have your secrets stored in Git. And this is actually great because you do not break the mantra of immutable infrastructure. And so you build the image, and now the build image step is not necessarily like a single thing that you use this one single box for building both application and your secrets. These can be 2 separate things. So you build the image, and via the build time secrets, you actually get your encryption key to the container. Now, I don't really care whether you use symmetric or asymmetric encryption. That's your choice, basically. So the thing is that we get the key into the build runtime of the image. So when we push all the secrets into the database, we can simply later on encrypt that image or the database inside the image using some key, and we will get this secrets database image with that nifty lock in the corner, which basically means that it is encrypted. And yeah, so then later on, and when you launch a container from that image, you actually use the OpenShift/Kubernetes secrets to provide the decryption key via regular secrets in Kubernetes or OpenShift, and you unlock your database so it's ready to serve all the secrets. Now, the nice thing about the workflow like this is that you can, for example, use like the methodology of principle of least privilege. That is like, I don't know, that's like the basic step that you can take when you care about security, is to make sure that if that container is not supposed to talk to some service, then don't give the container the token to talk to that service, because it doesn't need to. So this way, you can actually make sure that your container has only access to what it needs. And in the same way, now this fully depends on what secret as a service mechanism you choose, whether it supports access control list or whatever, if you can like further limit the access to the secrets through the API. So yeah, and the second very important thing is that the secrets as a service allow you to keep precise audit trail as to what is happening in the system. Because if you, for example, if you rotate your keys every 15 minutes, then it doesn't really make sense to redeploy your pods all the time. Because even if it's fast, it usually takes like 5 or 10 seconds to redeploy the given pod. But if you do it like every 15 minutes, then it means that in 15 minutes time span, your container is like 10 seconds down. And if you extrapolate that number throughout the entire day, month, year, and it's not a single container, but you've got hundreds of them, you may realize that your containers spent like 2 weeks being redeployed for no reason, simply because in the current state of the art, the lifetime of the secret is bound to the lifetime of the pod. But if you use secret as a service, this is not the case, because when you need the secret, you hit the service, you get the token back. When you are done with the token, you may hit the service again, and the key or the token gets revoked. And this is also, from my point of view, this is very important, because this makes the whole concept of security, it's not rigid. Whenever you decide, okay, I need to rotate this key or revoke this one, because I don't know, I feel bad and I feel like my infrastructure got breached. These things might have been stolen, so I simply rotate all things, and it's very simple. Because one of those quotes that I very much like in that regard is that it's this rule of security, that security at the expense of usability comes at the expense of security. Which basically means that if security is too hard to do it right, nobody will bother. So to make things really simple, please use secrets as a service. And I think that Christian will tell you much more reasons why this is a very good idea. And so, yeah, I was very quick.
Hey, super. Gives me more time to. Hi.
Thanks.
So, firing. Yeah, we have two microphones from two different recordings apparently. So can you switch over? So while Pavel switches over to my slides, just press the full screen. Well, yeah. So hi, I'm Christian Heimes. I'm a senior software engineer for Red Hat's security identity department, working mostly on FreeIPA and related projects. And one project already started by Simo and now developed by Simo and me is Custodia. So slides up. Perfect. So chapter 2, Custodia. So I'm going to do a quick intro into Custodia. I'll show you a bit of our design reasonings, why we designed Custodia as it is now. Then I go into Custodia for containers, because Custodia was not designed only for containers, but in general as a system to deploy secrets. I'll give you a couple of examples how we currently are able to integrate Custodia with different systems, stuff we'd like to do in the future, and finally questions and hopefully answers too. So, secrets are radioactive. Let's see how secrets are. That's actually not a screenshot from Fallout, speaking of vaults, but it's actually a game that was, I think, sold in the 50s with nuclear material, so kids can play with the new power. And that's how I see how developers have to deal with secrets right now. They are forced to play with very dangerous things, and what we like to do, we like to make it much easier and much safer for developers. So there's a German running gag. I don't care about nuclear power. I get my power out of my socket from the wall. And we like to do the same for secrets. We want developers not to care anymore about secrets, but just use a simple socket and API to get secrets. And let the security engineers with the hazmat suit deal with all this dangerous stuff. So let's meet Custodia. Custodia start with the word definition. So it's original Latin word. Means something protecting, safeguarding. It's also used in English, rather uncommon, to say something about caring, responsibility. There's also a relative word called PIX, means box, is used for storing the old compass on a ship. So if you lose your compass, it must be protected. You won't find home anymore. Or if you like Christian, hi Christian, the container for consecrated bread in the church is also called Custodia, the large one, or PIX, the smaller one. So you see, we try to protect your secrets and be very, very careful about them. So what's Custodia? Let's start from the beginning. It's currently a technology. It's not a ready-to-use product that you can just deploy now and it will solve all your problems. It's, as Pavel said before, it's secret as a service. It's an API. You can get secrets somehow. I'll explain later how it works. It works a bit differently than existing technologies used like Docker, Kubernetes. You actively push from like the kube daemon, the secret into a container when it starts up. We do the opposite way. We're going to pull a secret with the API. And it's not only implementation, it's also a definition how we're going to transport, how we're going to route secrets, because we want to have secrets maybe on the infrastructure. We have to find a way to get a secret through multiple hops. We have, for different reasons and for different use cases, different ways to define authorization, authentication policies. We want to make this pluggable. And Custodia is also currently the name of our reference implementation, written in Python. I'm a Python developer. I'm actually a Python core developer. Use the SSL model or hashlib model, mostly maintained now by me. Because we get that question rather often, what's Custodia not? Just to make it clear, we don't want to replace existing solution like etcd or OpenStack, Barbican, or HashiCorp Vault. They serve different use cases. So just not a replacement, it's an additional tool that can help you. It's also not just another store for secrets. We have internally implementations to store secrets, mostly for debugging and testing. Custodia is more a transport system for secrets, an API. And you can use this just to adapt the existing Vault solution. So you could write a backend that talks to HashiCorp Vault or to FreeIPA Vault or whatever is out there, or even to etcd. So we have etcd bindings. As I said before, it's not just for containers. We actually use that currently in FreeIPA a lot. And again, not proof of concept. Oh yeah, we use that. If you deploy a new FreeIPA cluster and you create your replicas, we use Custodia to deploy all these super sensitive things internally, like replication key, CIA private keys for RCA. So we trust that thing. Now, a bit deep dive into the design. When Simo started the process and the idea how we designed it, of course, we are security engineers. We started with threat analysis. So what Pavel already told you, we look at the current problem. Yeah, look at the current problems and then came to some results.
Is that a T rather than the threat?
Oh, sorry. Yeah, it should be a T, threat. Yeah, not like the threatening the danger. Oh shit. Sorry. Yeah, I'm not a native speaker, so. Gotcha. I should have reviewed the slides. So we don't want to have secrets on the file system because, as Pavel said, file system is rather bad. You can have traversal attacks when you have a web application and a couple of other places. It includes something like tempfs or even the proc file system if you have a variable there stored in the proc file system. We want to have strong encryption, not only at rest, but also in transit, which is a bit different than having end-to-end encryption, because since we have a routing protocol, we want to protect both the hops between the transfer between the hops and the entire chain with in two different ways. And of course, we want to reduce the amount of access that's required. So we basically don't want that the infrastructure that doesn't need to have access to secrets actually get access at all. So just want to have like the container get access, but why should like the Kubernetes daemon have access to a secret it doesn't need? Auditing, very important. We went to Paul Moore's talk. In a case a system gets compromised, you want to know which of the secrets got compromised, and if you just have to rotate a key, or maybe restart your complete CA public key infrastructure. So without auditing, you can't even know what's going wrong. Key rotation should be simple, part of the protocol, and that boils down to, if you go to the enterprise, PCI DSS compliance for banking, and so there are very strict rules that you have to obey to use deal secrets. So we have customers for banks in banks that want to use containers, but currently are having trouble to use containers because they have to obey PCI DSS compliance rules. These analyses led to some design principles. So again, it's much easier to prove that something works securely by reducing the attack pattern and require the application to actively pull a secret. Because if I just push a secret in a container that may or may not need the secret, yeah, we have a much bigger attack surface. So we pull a secret on demand. We want to use standard protocols because we don't want to reinvent everything on our own. It should be rather easy to write clients and servers and proxies and all the other tools we have. I wrote stuff in Python in my first Go programs. We have implementations using C in SSSD. Again, it should be also simple to deploy and integrate into the current infrastructure because when it's hard to use, as Pavel said, it makes it much more likely that you screw up something. And flexible. So we have different demands, different customers, different use cases. So all the authentication, that should be authorization too. Oh yeah. And storage should be flexible and pluggable. And also extensible. So we want to maybe support HSMs for big enterprise customers. We want to maybe generate a secret on demand. So when a service comes up and requires to have a secret, service should say, I need that secret, doesn't exist, please generate a secret for me according to a policy. And our service can then use that secret. Notification API for having a better way to restart a service when secret changes. So then we came up with the building blocks, obviously, for transport, what we use these days. So what do you use for transport? TLS? No, Pigeon. So yeah, TLS and HTTP. So simple REST API. We want to get something, we want to put a secret, we want to delete a secret. You can just use HTTP over TLS, as you said, or Unix domain sockets. And as message format, what these kids use today. So I'm from an area where we use XML, but these days we use JSON with optional Jose for key encapsulation. So encryption and yeah. We have as I said earlier, we have a storage layer abstraction where we have a couple of implementations. So a SQLite implementation is just designed for debugging and testing and for demo systems, so not something we want to use in production. For production, maybe later FreeAPI Vault, going into that. And even for simple cases, when your backend doesn't support encryption, we can do like an overlay. We wrap the storage in another storage that does just key wrapping and unwrapping. The pluggable authentication, we built a couple of things. Jesus API, Kerberos, TLS client certs. If you don't have Kerberos, if you use FreeAPI, you can use both. The other thing I'm going to into a bit later, that's related to the way Unix sockets can give you some nice features. And lastly, we use just the URL and rewriting of the URL to route secrets. So secret gets transported to multiple hops, and yeah, give you an example for that later. So when I have a simple interface for developers, so everybody can do just HTTP and JSON, even in C. And if you have PHP, Python, Java, Go, Rust, it's all built in. The different layers we have gives us rather good isolation and greater flexibility. We can just stack stuff. And with all the parts we put together and the routing, we can move the entire policies and the configuration, everything that's complicated, that's not the concern of the developer, to the infrastructure. The developer doesn't have to care anymore how the secret gets transported, how it's stored, how secret is processed. It just get the secret with HTTP GET and done. And what we're trying to do with a bit of standardization, we hope to establish a very simple, basic REST API that can be used, implemented by other vendors. We have already other companies, other vendors interested in the product or in the technology we defined. And yeah, let's see. So now, Custodia is not just for containers, but this talk is mostly for container people. So how does Custodia fit into containers? So with containers, we have one big issue. How do we authenticate an HTTP request from a container? So yeah, we could just get a secret into the container somehow, and then we have like a bootstrapping chicken and egg issue, because now we need infrastructure to get a secret in a container just to get a secret from our API, and but we can use a little trick. So who's able to spot the part that does the authentication? Is anybody able to spot the part or the element of the core query that takes care of authentication? No. That's just a request. So do a call request, and the answer is the JSON string at the end. So there's no authentication involved in that query itself, but rather the way how the query works internally, because it uses a Unix socket. And with the Unix socket, we can do some nifty tricks and just rely on the operating system to give us security and strong authentication. So what we do currently, it's a big ugly hack, something that's totally insecure the way it works at the end, but let's start from the beginning. So I have a Custodia container running that runs in the host PID namespace. So I can't run it in its own namespace for a reason you'll see later. And this Custodia daemon listens on the Unix socket. And this Unix socket then is bind mounted into the container. And for example, just before go back, this var run Custodia sock. That's the Unix socket device file. It's a file-based Unix socket. So then we use some of the features that's called getSock with the option SO peer credentials. That gives us the PID, the affected user, and the affected group ID of the process that just did the HTTP request. And that's guaranteed by the kernel that you can't do something bad with it. So the kernel ensures that you get correct information. The threat levels here, you have to compromise your whole kernel to do something bad. But if an attacker is able to compromise the whole kernel, the whole OS, yeah, you're screwed anyway. So we also can get, on an SE Linux-enabled system, the SE Linux process label. So the SE Linux contact the processor runs in. With both this information, we can then look into the proc file system, to the cgroup file, and use some regular expressions just to extract the container ID from the cgroup file. There's where the bad hack starts. And now it gets really scary. We also bind mount the Docker daemon into our Custodia socket and then use the Docker daemon to fetch additional metadata from the docket. That's what we want to remove. So did anybody attend to Paul Moore's? Yeah?
Question, does it mean you need to run Custodia on each house?
Yes.
So, and that Custodia has, each of them must have the copy of the secret database?
Come to that in a minute. So I have a diagram, next slide up. So did anybody attend to Paul Moore's talk about namespace and auditing? Yeah, my boss did, and the two other hands. So Paul is looking into a way to have like container IDs on the level of the operating system, so that each namespace or each container gets an ID. And what I like to have this ID, instead of using like the PID or the security credential, just use a simple syscall to get the namespace container ID from the Unix kernel and then add some meaning to that. So, but to get to your question, yes, we have to run Custodia on each node, but no, we don't have to have the secret on each of the systems because, again, Custodia is also a routing protocol. So we have the application running in a container, and we bind mount the Unix socket into the container, and then have the Custodia running, for example, in a daemon set on each of the hosts. And that instance running on each of the kubelets or VMs or hosts, going to the Kubernetes case, that you get information like the Kubernetes namespace definition from the Docker daemon or Rocket and rewrite the URL. So the container just says, get me the secret. This daemon verified the request, rewrites the URL and said, okay, namespace from tenant A, container or a pod name B tries to request the secret. That then gets rerouted to a Custodia instance running on the master using either TLS client certs or Jesus API for authentication. And now we can verify, is a container actually running on that machine with that namespace on that pod definition, and is it allowed to request that secret? And then we can talk to a key store, or maybe to even another Custodia instance that then gets the secret. You can just daisy chain them. And each of the Custodia instances can enforce a policy and verify each request with additional information. With that approach, we can even survive a compromise of a kubelet. So you isolate each customer on a virtual machine or on a bare metal machine. And so not two customers run on the same machine. Then it's possible to verify that customer A can never request secrets for customer B. One of the use cases.
Question.
Yeah.
Is it end-to-end encryption?
That's so HTTPS for the hops and end-to-end with Jose. So we can also do Jose. Then you have a middle step where you. Good question. We haven't fully figured out how you do it securely. Then we have to get somehow keys into each of the containers. But these keys you can bake in, like in your image, theoretically, or.
Sorry, in the previous
Yeah.
slide that
Yeah.
you had, that you explained how you get the secret.
Yeah. Now that's just.
The kernel authorizing the container, basically.
So in that diagram, we just get the metadata from the Docker daemon for the pod, like the namespace and the yeah.
But I tried to solve something very similar very recently, a few months ago, and it feels like a really big problem. My problem always with secret sharing inside a container is whether that container requesting that secret at that moment is a legitimate request.
So the question was, just to repeat, how to verify that the container at that point.
That the request that comes through the socket is legitimate.
So that's an issue we currently just can't solve with the way we have with the as a Linux policy, as a Linux context of the process and the PID. If you're going to have the container ID that's suggested by Paul Moore, for auditing, we can use the same auditing container ID also to verify the request.
But what about cases where the container ID don't change? So, for example, your application just gets hacked, and you just have access now to the Custodia socket.
Yes. Next point, how to do it better, but then you have to exchange your application to do software HSM. So that's a problem you can't solve with the way currently tokens work or password works. Where you like a software HSM, so digit auth, PKCS11, or how SSH and GPG agent work, you just prove that you have somehow access to a private key without actually having read access to a private key. You just prove you have the permission to do an operation with a private key. That could be theoretically, or almost running out of time, theoretically handled by having something like a GPG agent or a SSH agent similar protocol baked into Custodia. But then you have to heavily modify your application. So we want to make slowly progresses, slowly, yeah. So
So the danger about slow progression is that you can bake bad architecture in if you're not careful.
yes, I agree. But if you make it too hard, so then nobody will use it. So we have to.
If it's not secure.
Yeah. So just because I'm running out of time, a couple of quick examples how we can only able to integrate it. So make it easy for people, add it to your config parser. So you pass a config, and the config parser resolves the secret for you. So that's your config file. And for example, YAML parser, you pass YAML, and this magic dash Custodia, exclamation mark Custodia, signals the YAML parser to run a kind of internal extension, and that extension just does like container key, so get me the key for some string, and the application only sees the resolved key. Other thing you can, if you just look at our repositories, I've written a command to use the new Docker credential store API, and yeah. So a couple of years to integrate that, Java key store, PKC11, Ansible Tower, libsecret. So, sorry, yeah. Again, we haven't solved all problems yet. I'm right. So the question with end-to-end encryption, getting the keys in, still figuring that out. So it's not a magic pill. It's
Has this gone for external protocol review?
external reviews. The question was, did we have external protocol reviews? Not yet. So again, it's just technology and development. First we try to get some traction and some use cases. So we're now in the phase where we think it's good enough to let people play with it, and it's not a ready-to-use product. It's technology work in progress. So the part where we use it in free API, again, I'm out of time. We can use Jose because we have to use the API to get the keys. But we can just talk. 5 minutes for question. More questions. Sorry.
The token, which is used for authorization of the API request, and which is obtained via a Unix socket, is it unique per pod, or is it the same for all the pods on the particular host?
So the question was the token to get the secrets from the Unix socket.
The secret used for authentication of the HTTPS request.
In the Kubernetes case, each of the machines has machine credentials. For example, each machine has its own private public key pair to use TLS client-server authentication, or its own Kerberos key tab to do service-based authentication. So we can then verify that the request came from that machine. We partly trust the way, so we have to trust the kubelet daemon that it tells us the right container it's asking for a machine. We then can verify that that container actually runs on that machine. But theoretically, the system could still lie, say, I'm running 2 containers on the same machine, and the secret is requested for another container. Not this. So there's still a trust chain. We have to trust part of the system for each of the steps. But the other way, if you use Kubernetes secrets, you trust that you push the secret into the correct container when you start a container. So it's not, at least the way I understand, I'm not a Kubernetes expert, as far as I understand how Kubernetes works, our approach is not less secure than the current approach by Kubernetes. Any more questions? Ah.
Sorry, I can't stop myself.
Go ahead. We still have like 4 minutes to go for questions.
From my experience, I try to use both, passive or default,
Yeah.
right? So one of the biggest struggles was to persuade developers to actually use my APIs. And one of the most frequently asked questions I had was, okay, our app is very high performance, and what happens if we rotate that key, like you say, every hour or so? What happens with our connection pool to the database? What we have now to rotate slowly the connections and wait them to dry and bring up new connections with a new secret?
Okay, you're describing. So the question was.
So the question is, rotation and all those features get very complicated for developers. So we're brought back to what you said.
So the
Stability and security.
the question was, or the
question is, how are developers approaching this? Do they like solutions like this? Are they going to embrace a solution like this?
May I comment on that?
so sure. That's the boss is my boss. So
So one of the ideas that developers really like with this approach is putting API into JVM secret store, so that you provide secrets for the JVM, and the developer doesn't care where the secrets come from. But ops folks, when they hear about that, they are really excited because they configure the host once with its identity, and that's it. It's then a part of the infrastructure, and the developer just talks to the local key store through the standard APIs, and
So-
everybody's happy.
that's the slide I skipped a bit. So Java key store is just a standard API to get a secret for a running Java application. Or what you probably know or not know is so KDE keyring and GNOME keyring use internally something called libsecret. That's just a library that can you compile in, has some C API where you use session dbus to talk to your keyring. And we like to do something similar, just to hook in the libsecret, but for a headless service. So using the system dbus, and so these are ideas we have. Or for OpenStack, hook into Oslo config. So yeah.
I'm not criticizing, but
Yeah.
because I try to persuade developers to use actually something, I had lots of questions from them, and it's like playing the devil's advocate. I'm building something. Why am I doing that?
Okay. Before I rephrase you in your experience, you had issues to convince developers to use your API because they didn't see a point or was maybe too hard to use. That's why we like to standardize on a very simple protocol using like HTTP and JSON that can be easily implemented. You can write multiple clients for that or integration points. And if we get multiple companies, multiple departments inside Red Hat, outside Red Hat, behind the very simple API, then we can work on top of that and extend. But first we have to show that having an API is much better than baking your own solutions. Yeah. So that's,
I have actually a question related to this slide. So
Yeah.
how about Kubernetes secrets? Will it be able to use Custodia as a Kubernetes secret like that?
we have like a replacement thingy because there would be in that slide where you just run, instead of the original app, just have like a facade in front of that, and then we inject, for example, secrets or drop files. That would be a step to use Custodia API without changing your application, even changing the container. Again, you still have the issues. You have the secrets on the file system or an env-var, but at least you could use the API without modifying the image. Out of time. Sorry. Already like 30 minutes over. So if you have any more questions, feel free to contact me. Oh well, there is the guy coming for this.